Welcome to session 5 of Unit 1, and in this session we'll be looking at integration of other functions. By the end of this session, you should be able to appreciate the concept of integration of other functions, and you should be able to determine the integral functions of sine, cos, and then that of logarithms. Now, we have played with y is equal to 2x enough now. So how do we integrate other functions? If you are lucky enough to find a function on the result side of a derivative, then using your knowledge that derivatives and integrals are opposite, you have an answer already. But remember, you always have to add c at the end of the integration. Now we have some common functions and then their integral form. So if you have a constant, or anytime you integrate a constant, then what you intend to get is the constant as indicated here. So if we are integrating a, then we are going to get a to the power x plus c. If you are integrating a variable, then it will always give you that variable to the power 2 divided by 2 plus c. We will show more examples of this nature. However, this assuming that here is 1, x to the power 1, then we are going to get x to the power n divided by n plus 1 plus c. So in this case, assume that x is to the power 1, then we are going to have n plus 1, which will give us 2, over n plus 1, which will give us 2. So that is why we have x squared divided by 2 in this. And if you are integrating a square, then your end result is going to look like this. So we can integrate some common functions such as reciprocal, exponential, trigonometry, and remember, in trigonometry it is always in radians. Now let's look at some of the rules of integration. We've talked about the rules of differentiation, where we looked at multiplication by constant, we've looked at the power rule, we've looked at the sum rule and the difference rule. We've also looked at the product rule. And in integration, we'll also be looking at multiplication by constant, we'll be looking at the power rule, we'll be looking at the sum rule, and we'll be looking at the difference rule. Let's take the power rule as a start. If we have a function x squared, what will be the integral form of this? Or if we intend to integrate, what will be our integration? So the question is asking, what is the integral of x to the power 3? We can use the power rule where n is equal to 3. And if n is equal to 3, then, like I said earlier on, anytime we are integrating using the power rule, then it becomes x to the power n plus 1, all divided by n plus 1, plus the constant. So in this case, n is equal to 3. Therefore, our final answer stands to be x to the power 4 divided by 4 plus c. Let's take a look at another example. What will be the integral of the square root of x? You realize that in this case, we need to rewrite the square root of x as x to the power 0.5. We can then use the power rule where n is equal to half. And when n is equal to half, then substituting that into the formula gives us x to the power 1.5 divided by 1.5 plus c. Next, we will look at the multiplication by constant. Taking this as an example, what is the integral of 6x to the power 2? We can move out the 6 outside the integration form and then deal with the x to the power 2, then we multiply by the 6. So in this case, we have 6 outside the integral x to the power 2, and now the power rule can be applied on this. So in this, we are going to have 6 to the power 3, 6 times x to the power 3 divided by 3 plus c, which in essence will give us 2x to the power 3 plus c, because the 6 can divide 3, or the 3 can enter into 6 2 times, and we'll get 2x to the power 3 plus c. which is our constant. With the sum rule, assuming we are going to find, or as an example, the integral of cos x plus x dx. To use the sum rule, first we have to integrate cos x plus x dx, which will give us cos x, or the integral of cos x plus the integral of what, x. So what simply happens here is we integrate one of the components separately, then after our integration we add them together. So we have to work out the integral of each using the previous table. So we all know that sine, the integral of this would result into what, sine x, because the integral of cos x will give us sine x, plus x will give us x squared divided by 2 plus c. So the integral of this function will result into sine x plus x squared divided by 2 plus c. Now the difference rule. With the difference rule, we use the difference rule, for instance, integral of e to the power w minus 3 dw. Remember, it is not only x that we can integrate. We can always represent it with other variables such as a, b, c, d. Any variable of your choice or that makes you feel comfortable, you can always use it. So to use the difference rule, work out the integral of each using the table provided earlier on. So for instance, what is the integral of 8z plus 4z squared minus 6z squared dz? To use the sum and difference rule, we are going to combine this. So you will need to find the integral of this first, find the integral of 4z to the power 3, find the integral of negative 6z to the power 2, then we add and subtract them. So to do that, the constant multiplication of 8 to integral z plus 4 integral z cubed minus 6 integral z squared will result into 4z squared plus z to the power 4 minus 2z plus c. So the integral of this function will result into this particular simplified equation or arithmetic. Now, when we talk about integration, we can talk about two different types of integration. We can talk about definite and indefinite integration. So looking at this pictorial diagrams, you realize that with indefinite integrals, we are not limited, but in definite integral, we are looking at from one point to another point. So when there is a change from one point to another point, then we can find the integral. However, in indefinite integral, then we are looking at an indefinite value. So the definite integral from 1 to 2 of 2x, that actually means that we are looking at the integration of this function, or when x is equal to 2 and when x is equal to 1. So the indefinite integral is basically represented by the stylish as 2x. So with definite integral, there is always the point or the points in which the integration starts and ends. But with indefinite integral, that is restricted. You are not given any limitation, or limitations are not bounded. So for instance, the definite integral from 1 to 2, which means at x equal to 1, what will be the integral? At x equal to 2, what will be the integral? So after we are done with this, we need to subtract 2 square plus c, which is the integral of 2x. So we are going to have 2 square plus c minus 1 square plus c. Then we are going to have 2 square plus c minus 1 square minus c, which is equal to 4 minus 1 plus c, which is equal to 3. And c gets cancelled out. So you realize that with the definite integrals, we can always ignore the c, because at the end of the day, because we are moving from point A to point B, then it turns out that Since we are looking at subtraction, the positive and negative are going to cancel out, making it cancelled and then giving us a 0. In other words, it does not appear in our final answer. So to simplify things further, the integral of 2x from point 1 to 2 would result into a figure or a value 3. Now, the definite integral from 0 to 1 of sine x dx. So the definite integral will give us when x is equal to 0 and when x is equal to 1. Since we are going from 0, we can just calculate the area at x equal to 1. So that is negative. Remember, the integral of sine x will always give us negative cos x. So when x is equal to 1, we can simplify negative cos 1 to give us negative 0.540, and that's the area at which that's the area at x equal to 1 is negative. Now, because we forgot the plus c, which is important, we can only ignore c when it gets cancelled by subtraction. So we have to do it properly, subtracting one from the other. So if I have the integral of sine x from 0 to 1, then we are going to get negative cos 0 minus negative cos 0, negative cos 1 minus negative cos 0, sorry. And this will actually give us negative 0.54 minus negative 1, which will give us, because cos 0 is 1, which will give us, now this would turn us to be a positive figure. So negative 0.54 plus 1 will result into 0.460. To sum up, in this section we've looked at integration of other functions, we've looked at definite integration and then indefinite integration. We said that definite integrations are where we are moving from one point to another, and then indefinite integration is where we are not restricted to any point difference. Thank you, and I hope to see you in the next session.